Hello, grade 9s. Okay, so today's lesson, we're taking a look at properties to a tangent to a circle. So as we're going to do this, first of all, what I'm going to do is I'm going to get a circle out. So I'm going to use a compass here to make a circle. Okay, and so as I do this, all of you guys should understand what a circle is. First thing I'm going to do is I'm going to mark the center of my circle. So here's the center of my circle. Okay, and let's just make a circle here. Okay, so here I'm just going to make a circle. Use my protractor. Oh, sorry, it's compass. Make a circle. Okay, so I got a circle made. Now I'm going to put a point on the outside of the circle. Now to understand tangents, it's basically like this. So let's say I take a line from this point and I go through the circle. So this line has intersected the circle here and here. So it's intersected the circle twice. Now let's say I get another line, okay, and another line, and I'm going to go through the circle. Well, guess what? This circle, or this line, has intersected the circle twice as well. Okay, so now I'll make another line, and I'm going to go from here. Oh, and it just skims the top of the circle. So now this line has intersected the circle once. Okay, if I make another line, okay, I'm going to make another line, and I'm going to also, let's say it just skims the top of the circle, where it intersects the circle right at, I guess we could say almost the bottom part of the circle. So now it's intersected the circle once. Now, if I call this, let's say I'll call this line A, and I'll call this line B, C, and D. Well, line A and line D are tangents. Line B and C are not tangents. So a tangent line intersects a circle only once. And so it's intersected the circle here, so it's a tangent line. Line D has intersected the circle only once, so it's a tangent line. But lines B and C are not tangents because they've intersected the circle twice. So they're not tangents. So what I'm going to do is I'm going to actually just get rid of this line, okay, and I'll get rid of this line. So we just work with just these lines. Okay, so now line A and D we say are tangents. Okay, so I'll just write that down. Line A and D are tangent to the circle. Why are they tangent to the circle? Because they intersect the circle only once, and that's super important. Now, this point right here, where it intersects, we call that the point of tangency. Okay, and so this point over here, it intersects the circle only once, so that's also we call the point of tangency. And if I can write properly, there we go. Point of tangency. Now, this was the center of our circle. I'm just going to write C for center so we know that there. Now, here's something that's super important. From the point of tangency to the center of the circle, that is something that we know as the radius. Okay. So now, here we have line A as our tangent. This line right here, that's now the radius. Okay. And now, we can see a relationship between the radius and the tangent line. And if you didn't notice it, the radius and the tangent line forms a 90-degree angle. Or we could say that the radius and the point of tangency, or the tangent line, is perpendicular to each other. And when they are perpendicular to each other, it forms an angle of 90 degrees. Okay, and the same would be true if we took a line from this point of tangency and went up to there, this also would be a 90-degree angle. So these two lines are also perpendicular to each other. So in this case here, we have two perpendicular lines, and so therefore we have two 90-degree angles. Now, like I said, that's super important for us to understand this. Okay, so the tangent line right here is perpendicular to the radius. And so this tangent line here is perpendicular to the radius, and so therefore forms a 90-degree angle. So now let's take a look at how this could be useful to us here. Okay, so here's an example. It says find the measure of an angle in a triangle. Now, this is kind of an easy question because one thing that we need to remember is, first of all, it says what is the measure of all the angles in a triangle? And if we remember that, okay, we know that all the angles in a triangle add up to 180 degrees. Okay, so if we take a look in this example, we have a missing, hang on, let me just make this a little bigger. There we go. So we're told this angle here is 63 degrees. Now, look at the question. It says determine the measure of angle OBA. So what's OBA? So we start when we look for angles, we look at the middle thing here, which is B. So here's B. So now we go OBA. So this is our missing angle. Now this angle is 63. We're told that. So what about this? This angle right here is perpendicular to this, or this line is perpendicular to this line, so we know it's 90 degrees because this line, line AB, is perpendicular to line AO, so therefore it's 90 degrees. And we know that AB is a tangent line. So if that's the case, now let's find our missing measure. Now I'll just use, I'll say that this is x degrees. We don't know what that is, so that's our unknown, but we can easily figure it out. What kind of math do we do? Well, we're just going to do some adding and subtracting. So if I know that all the measures of all the angles in a triangle is 180 degrees, okay, so then I'll use that to figure this out. So I'll say x, to find x, I'm just going to go 180 degrees, and from that I'm going to subtract 90 and 63. So I'll add those two up. I get 153, subtract 180, do that math, and I'm going to get x is equal to 27 degrees. So therefore, this angle OBA is equal to 27 degrees. I think that's kind of fairly straightforward. Hopefully you understood the math that we did there. Let's take a look at another example. This one is we're going to take a look. We're going to use the Pythagorean theorem. Now, remember what the Pythagorean theorem is all about. And we only use this with right-angled triangles. Remember, the Pythagorean theorem, okay, if you don't remember, was simply a squared plus b squared equals c squared. And this works only with right-angled triangles. Okay. And when we have a right-angled triangle, we can find a missing length in a triangle. So if we take a look, I've got this side is equal to 20, this side is equal to 15 centimeters. But we'll have to figure out where is my right angle. Okay, so I have line CD is perpendicular to line CO because line CD is a tangent to this radius. So that means that this is the 90-degree angle, this perpendicular, so it's 90 degrees right there. Okay, now when we do this, we need to understand, well, what do each of these letters represent? And this is just a review. A and B represent the two legs of a right angle. C represents the hypotenuse. In order to identify the hypotenuse is always opposite the right angle. There's a right angle, across from the right angle is the hypotenuse. Okay, so now I've got that. Let's actually look at the question. It says point O is the center. Here's point O, that's the center. And CD is tangent to the circle. CD equals 15 centimeters. OD equals 20 centimeters. Determine the length of the radius OC, okay, to the nearest tenth of a meter. Now I just said that OC, we're going to use A to represent OC, that's our unknown. Okay, I'm going to start with just writing out the Pythagorean theorem. Okay, so I have A squared plus B squared is equal to C squared. Okay, so now let's look at this. So A squared, well, I don't know what that is. So I'm just going to leave it as A squared. Now if I take a look at B I said, or not I said, but we're told is 15 centimeters. So I'm going to square that. And C is the hypotenuse. And here we're told it's 20 centimeters. And we're going to square that. And if we go ahead and follow the math, 15 squared is 225. 20 squared is 400. A squared is still just A squared. And now we know we have to isolate our variable, remembering our basic algebra. I'm going to isolate A squared. That means I have to get rid of 225. I'm going to subtract it from one side. What I do to one side, do to the other, so it's subtracted from both sides. Here it cancels out. Here it simplifies to 175. And so all I have left over here is A squared. So I have A squared equals 175. But I can't leave it as A squared. I have to get it to just simply A. So I'm going to take the square root of both sides. If I do to one side, do to the other. So A squared, the square root of A squared is just simply A. Those two cancel out. And A then is equal to, if I do this on my calculator, 13.2. So now, what does that mean? That means that the missing length is 13.2 centimeters. So over here, so this is 13.2 centimeters. Okay, so that is basically it for today. So just understanding how we use the tangent in solving problems. So if I go back to my question here, what I really need you guys to understand is that the tangent line right here is always perpendicular to the radius. And how do we identify a tangent line? Well, a tangent line intersects the circle only once. So this line A, started from here, intersects the circle once. So that's the tangent line. The tangent line is always perpendicular to the radius, and a perpendicular angle is always 90 degrees. When we know that, then we can solve problems like this and like this, what we just did. Okay, so I'm going to give you guys some work. I'll post it in Classroom, but at least you guys understand. Hopefully you understand what we just did. Okay, bye guys.